And let's talk about the mean value theorem. Mean value theorem, or MVT, for integrals. I mentioned this briefly at the sort of tail end of yesterday's class, but I want to give you a little bit more information about this so you can try these questions. The mean value theorem. Of course, the mean here, mean means average. Mean means average, the average value theorem. And so what we're looking for with the MVT, it finds the average value of a function on an interval. Average value of a function. So if I have some function f of x, and I go like this, right? Or let me do a better graph, right? Like this, right? Some function like this. At some point, right, we have certain heights, right? We have the like a low point down here. Here's our low point. Right? We have a low point. We have a high point. There's like various amounts of this function here, right? Like it goes up here, then it goes down, then it goes up real high. So the question is, where in this function, what is the average value of this function? And so somewhere, right, you can imagine like a middle, like here. This is f of c. This is the average value at some location c on the interval from a to b. So like we have a low point, right? We have a low point here. We have a high point here. And this average value is like the middle. Basically, it's the middle of the graph. It can be more complicated when you have a graph that goes up and down and wiggles around, right? Sometimes you have multiple average values. It hits the average somewhere along the line. And so what we're looking for, this f of c, is the average value of a function. And so to find f of c, the mean value theorem says if f of x is differentiable on the interval from a to b, there exists f of c, where it's 1 over b minus a, integral from a to b of f of x dx. Then there is a c. There is an average value c such that f of c is this average here. So the mean value theorem finds the average value of a function. These are the notes for the assignment. Notes for the assignment. So let me give you an example of what this means. So let's say a car's velocity is modeled by the equation v of t is t squared minus 3, t squared plus 3, sorry, t squared plus 3, on, I should say, over a 3-hour drive. Over a 3-hour drive. find the average speed, of the car from start to those 3 hours. When the car started driving to the end of those 3 hours. Okay? So this is what we're looking for. We have some speed, some velocity, right, modeled by this equation here, over a 3-hour drive. And I want to know what is the average speed of the car if this was its speed. This is speed, everyone, speed. Average speed of this car in that 3-hour window, from when it started driving to when it stopped driving. In that 3-hour window, what is the average speed of the car? So we have this equation here. We could graph this equation and take a look at what it looks like and kind of guesstimate what the average velocity might be, right? If we look at a graph of this equation, 1, 2, 3, it's going to look something like this, right? From 0, 1, 2, 3. This would be approximately, I mean, like I'm a little off here, I'm sure, but approximately what f of x looks like. Oh, what v of t looks like. V of t. The velocity function would look something like this, right? And we want to know what is the average velocity from 0 to 3. What's the average speed of the car? Is it 5 miles an hour? 10 miles an hour? What's the average speed of this vehicle? Okay. So to find that average, we say f of c equals 1 over b minus a, integral from a to b of f of x dx. Well, in this case, our equation is not f of x, but it's v of t, which is the same thing. Doesn't matter, right? So f of c is 1 over b and a. Here's a, here's b. So I'm going to go 3 minus 0 of the integral from 0 to 3 of t squared plus 3 dt. And this is going to give me the average. This is going to give me the average value of the function over that period of time. And now I have to do the integration and multiply that integral times, this is just a multiplier. This is a 1/3 out front, right? 1 over 3 minus 0 is 3. So this is just like I'm going to multiply whatever my answer is of the integral. I'm going to get a number answer for this integral because it's a definite integral. I have starting and stopping places. I'm going to get a number for this. Multiply that times this value here and get my average value. So what's this going to be like? This is 1/3 times something. Well, I got to figure out what is the integral of t squared plus 3 dt. What is the integral of t squared plus 3 dt? We'll do the same integral rules we know before. T squared, the integral of t squared is t cubed over 3. Right, I add 1 to my exponent here, plus 1 to the exponent, and divide by the 1/3. So add 1, add 3, then divide by 3. So t cubed over 3. Plus my integral of 3, remember when we're doing an integral, we are adding a variable. So this is going to be 3t. And I evaluate that from 0 to 3. So I'm going to plug in from 0 to 3. So it's 1/3 times, plug in my 3 first, I get 3 cubed over 3 plus 3 times 3 minus 0 cubed over 3 plus 3 times 0. So that's really a 0 there. Remember what I did, right? I plugged in my values here, my 3 and my 0. Plug in my 3 here, and plug in my 0 here and 0 here. And I have these two pieces of my equation, right? It's this one, it's this piece minus this piece. That's a 0. So we did our integral. We plugged in b minus a, integral of b minus f of b minus f of a. We're going to calculate this and get a number for our answer. So this is going to be 1/3 times, let's see, this is 0. So 3 cubed is 27 divided by 3 is 9. So it's 9 plus 9 minus 0. So 9 plus 9, that's 18. So it's 1/3 of 18. Oopsies, 18. Which is going to be 9. 9, miles per hour, whatever the average speed, whatever we're talking about here. Velocity in miles per hour. So my average speed from here to here, the average speed of this graph is 9 miles an hour. Here's my average. Smack in the middle of the graph, whatever is the middle. It's not quite exactly halfway, right? It's not going to be exactly halfway between 0 and 3. It's not exactly halfway because there's a little bit, like this goes a little bit higher and this is a little lower, right? I mean to say this grows a little slower, right? This is like a little flatter and this is a little sharper, right? As our equation grows. So it's not going to be exactly halfway in the middle. It's going to be a little off, right? A little off from exactly halfway in the middle. Because if we imagine cutting this up, this area and this area have to equal each other. That's what average means. It's the average of the area of the graph. Where's the middle? Well, the areas have to be equal to each other. Area 1 and area 2 have to be equal to each other. And the place where that happens is where the speed becomes 9. That's my average velocity starting from 3 going up to, what's the highest point here? Let's see, 3 squared, this is going to be 27. 3 squared is 9. No, this is going to be 12. So from 3 to 12, my average speed is 9. All right, again, not exactly halfway in the middle. Not exactly halfway between 3 and 12. Average speed is 9. And it depends on the shape of the curve, right? The areas are going to be different sizes, so the graph, the average point moves a little bit to the left or right. So when you're finding an average, this is what you're doing. You're locating the point, the value of the average of all the y values as they go up and down at different speeds, different rates. That's what this integral helps us to do, find this average value as the graph goes, right? This is a little bit lower, a little flatter. This is a little sharper, right? So it's kind of like less maybe over here, more over here. Got to find these average areas, these equal areas, and that happens at 9. So that's how we can find the average, using our formula, do the integral, plug it in, 1 over b minus a, find the value. There's a part B though, whoopsies. Now that we know the average value of the function is 9 miles an hour, part B says, find the time t where the car is going the average speed. In other words, you are finding the c value. Find the value of c. We know that f of c equals 9. We know that this is true. We know that the value of the average speed is 9. But what's the c value? What x value, what location, what time along this graph, what time am I going that speed? And there may be more than one, right? If our graph goes up and down, we're going to maybe touch the c value multiple times. So how do I find the value of c? Well, it's very easy. We know the f equation. We know the equation for f, right? This function f is, well, I say f, it's really this v equation, is the equation we have. This is my function. And I want to know where it's 9. So, okay, well, I say this equation has to equal 9. Oops, I want to make the equation 9. Goodness gracious. I know the function is 9, so I know that v of t has to equal 9. So that's going to be t squared plus 3 has to be equal to 9. Okay, I can solve this. Minus 3 on both sides, minus 3 on both sides. T squared has to equal 6. Do the square root, do the square root. T is equal to plus or minus square root of 6. Right? But the minus square root of 6, right, which is what? Let's see, square root of 6, if I do that calculation, is going to be in a calculator 2.45, which is about 2.45. 2.45 hours. At about 2.45 hours, that's when we find we are at the average speed that we've gone. So we just plug in the 9 into the formula, right? Plug in f of c and solve for t. So that's how we find the average value, and you can use that to find the c value by plugging in, setting the function equal to that value, and solving the equation. Okay? Questions about this process? So this is the last thing I wanted to tell you about for the mean value theorem, how to use it to find these pieces of information. How to find the average value of a function over a period of time using this formula, 1 over b minus a, integral from a to b. Find the integral, plug in the integral values, multiply by this 1 over b minus a, and you get your average. Then you can take that average, set the function equal to that average, set the function equal to the average, and then solve for the variable. Where is it 9? It's 9 at about 2.45. About 2.45. Close to 3, right? Really close, 2.45. Much closer to 3 than it is to 0. You're going your average speed at 2.45 hours. Questions about this? All right. All right. So let's go over the assignment then, and let me show you the questions for this assignment. Let's try this homework together.